Hi, hello. Today we are going to talk about what is a data test. In a data test, there are three types of questions: apply understanding, analyze evidence, interpret evidence. Okay, so normally speaking, interpret evidence would be more difficult than the other two, and possibly applying understanding would be the easiest one. So let's say it's more difficult. Okay, so before you start the test, it's really important to know that in the data test, you are going to have a list of formula. You need to understand what these formulas are about. Let me show you. Okay. At the start of any data test paper, okay, there will be a list. Because what we are going to do is it's a data test based on our understanding of thermophysics. So most of formula are related to thermophysics. Alright, so you should know all these formula before the data test. Okay, so there are some statistics formula which might be a bit strange to you guys, but you need to know that this formula should be the one we have studied in the lesson. Okay, so let's give you a question to try. Okay, so let's do this data set 3. Okay, so for the data test, that will start with a description of an experiment. So you need to read the description very carefully. Okay, so let's copy this part. Okay, so that's the description. Okay, so let's see what's the important information in here. Okay, conducting an experiment setup. Okay, the student plays 100 gram. Okay, so 100 gram is a quantity. So normally if they give you a quantity in terms of numbers, then it's very likely that you have to use this number, so you need to keep that in mind. Okay, of an unknown substance in calorimeter and heated using an electric heating element. By using an electronic power source, students were able to measure record both for energy input and to the calorimeter and the temperature of the substance. Okay, so let's see if we can make sense of this description by looking at the experiment setup. Okay, so here's the setup. Okay, let's see. Okay, first they said the students place 100 grams for unknown substance. Where's the unknown substance? Of course, in that calorimeter, well, it's a shape, it's a cup-like container. So you got a unknown substance, right? And how about electric heating elements? Of course, you see that's a heater. Okay, and power source. So here's a power pack. Okay, so basically it makes sense of all of these things. Then you need to know that the experiment was conducted 3 times and the result recorded in table 1. So where's table 1? Okay, let's have a look. Okay, so here's the table 1. Okay, so now possibly you need to spend a bit more time to understand what's the table about. Okay, to understand a table, first of all, you need to notice what's the quantity for each column. Okay, so here's the energy given. Okay, So, and the unit is joule. Okay, sometimes some student might miss the importance of the unit, but here is joule. In some case, it might be kilojoule, so they are different, right? And then the second one is the temperature. Okay, so basically it's the energy on the first column and the temperature for the next three columns. Why there are three columns? Because there are three different trials for each energy input. Okay, so that's why, because they have three different temperatures for each energy input, so that would be an average temperature. Okay, so need to think, how could that average temperature link up with the previous three data? Okay, so, and you need to get a sense of it. You see that 30 degree, but you see that three data 30, 31, 29. So how could we get this 30? Possibly we take the average of these three. Okay, so if you understand this, then it would be very useful for you to answer the questions in the following parts of this question. Okay, so you might see something strange here. You see that's a missing box here. So possibly this is the part that you need to fill in. Okay, right? So it's not a printing mistake. Okay, let's add more names to paper. Okay, so if we understand this table, then we look for the first question. Okay, so when you look at this question, okay, first of all, you need to notice what kind of question it is. It's applied understanding. Okay, it is applied understanding. So normally applied understanding should be the easiest question in a data test. Okay, so normally the mark won't be too much. It would be like 1 mark. Okay, and then you might see a box here. Why there's a box? So whenever it's a calculate, okay, it's a calculation type of question, then they will give you a box for you to fill in the answer. And there's units here. So it's a good reminder what kind of answer you are looking for. Whenever you see the box, that means you need to get a numerical answers rather than a description. Okay, right? So the first one is calculate the average temperature after 4,000 joules of heat has been supplied. Okay, so how could we calculate the average temperature? So the key terms here is average temperature. Do we know how to calculate the average temperature? Yes, we do. Why? Because in the formula list, there's a particular formula for the average temperature. Which one it is? Okay. Yes, should be this one, right? Okay, let me copy this one. And so, suppose we use this one. Okay, so that's why it's called applied understanding, because you apply the formula to show you understand how to get the answer. So that's why it's applied understanding. Okay, so we're going to use this formula. So what do we need to fill into this formula? Okay, so you see that in the numerator there's a summation sign for multiple temperatures. So there are more than one temperature. Okay, why there are more than one temperature? Okay, and you see that after 4,000 joules, so 4,000 joules means we go to here, so that's 4,000, right? So after 4,000 joules is applied, so there are three temperatures. Okay, so that's why you are going to find this one, right? Okay, so how could we use this formula? So because there are three temperatures, all you need to do is add them. and you divide all of them by 3. Okay, so that's it. Okay, so and then you, of course, you use your calculator to find the answer. So what would be the answer? Okay, so it should be 45.5. Okay, so you fill the final answer right here. Okay, check, that's 1 decimal place. Is my answer 1 decimal place? Yes, then it's done. Okay, so the first question is really simple. It's apply understanding. All you need to do is apply formula, okay, and put into correct numbers and use the correct substitution. You get the answer. Remember to fill your answer into the box, and also make sure you track the number of decimal place or significant figure you are asked to do. Okay, so that will be the first one. So let's look for the second one. Okay, so the other one is also apply understanding. That means it won't be too difficult. Okay, so let's see. Okay, so this one is again is apply understanding, right? Okay, so what's the major collective word? It's determine. Okay, so determine what? Okay, the absolute uncertainty. What's the absolute uncertainty? We're not quite sure about. Okay, if you are not quite sure about this, what's the absolute uncertainty of mean? Okay, for what? For the temperatures. Okay, if you're not quite sure about, look at the box here. Okay, so what's the box? So if there's a box, there must be a numerical answer, right? So, and you see the unit is degrees Celsius. Okay, so you need to answer a temperature in terms of numbers. Okay, so absolute uncertainty mean for the temperature. That's why the answer should be a temperature in the different trials after 4,000 joule of energy. Again, it's about the 4,000 joule of energy has been added to the substance. So what's the absolute uncertainty of mean? We are not quite familiar with this one, alright? But if you are not quite familiar with this one, it should be in the list of formula, right? So let's go back to the list of formula. So you see there's absolute uncertainty of the mean. Okay, actually we do have one. Alright. Okay, so that's what we are going to use. Okay, so we are going to use this formula to find the maximum minus minimum divided by 2. What's maximum? What's minimum? Of course, it should be the maximum temperature and minimum temperature. Okay, for the 3 trials when 4,000 joule has been added. Okay, so you see there are 3 temperatures right here: 46, 45, 45.5. So which one is the maximum? Of course 46. Which one's the minimum? 45. Okay, so according to the formula, what you need to do is to use 46, take away 45, divided by 2. That's it. So use your calculator. You see that should be 0, right? Okay, should be 0.5. Alright. Okay, but be careful, because your answer should be correct to 2 decimal place. If you write 0.5, okay, so only 1 decimal place. How could we do that? Even your calculator might tell you the answer is 0.5 because you have used the maximum minus minimum. Okay, so the calculation is right, the calculator is also right, but the answer is not right because you need 2 decimal place. What should we do? You just add 1 0 here. That will do it. Okay, so remember this. You need to track number of decimal place. Alright. Okay, so that will be our next question. Okay. So the first two questions are actually not that difficult, because all you need to do is to apply the formula, okay, given by the test. Okay, so how about the next one? Okay, the next one you see, okay, becomes a bit more challenging. Okay, it becomes a bit more challenging because it's analyze evidence. Okay, analyze evidence. What do you mean by analyze? Analyze means you need to break down something, extract something from the data. Okay, how could we extract something from the data? Okay, so you see they use a cognitive word, identify. Okay, so when you just look at the identify, you don't know what does it mean, but at least you know that it should not be a numerical answer, because there's no box right here. And identify what, so you need to look further. So relationship. Okay, so relationship, so whenever we talk about relationship, it should be between at least two quantities. Okay, so you need to find out what are the two quantities you are going to find the relationship. Okay, so between the heat, okay, so heat will be one, heat added will be one quantity you need to look at to the substance, and the temperature. Okay, so you are looking for the relationship between heat added and the temperature of the substance, and you need to use evidence from the table 1 to support your answer. Okay, so let's go back to the table 1 and look for the heat supply and the temperature. Okay, so basically what it means is like, okay, you need to use this column, okay, the data in this column and the data in this column, okay, to make a comparison so that you can see the trend of these two sets of data. Okay, so let's remember that the data missing here should be 45.5, right? Okay, so what do you see from this one? How can we get a relationship out of these two sets of data? Okay, first you need to see whether when one data getting bigger, the other data also getting bigger. Okay, does we have that trend? You see, okay, so when the energy input becomes bigger and bigger, okay, so it's increasing, right? So it's increasing. That's right, it's increasing right here. Sorry for my handwriting. And you look for the data right here. Okay, possibly I should use another color. We look for the data right here. You see, it's also getting bigger. Yes. Okay, also increasing. Okay, so basically we could say the greater the energy input, the greater the temperature, the greater is the average temperature. Okay, so that would be the first relationship. Okay, but is that only first relationship good enough? You see, that's 2 marks. Okay, so possibly you need to look into more details. Okay, so let's see. Okay, so each time you see that each time the energy is increased by, I need to use the color. Okay, increased by 1,500, and then here's 500, right? That's 1,000. Okay, so right, so and then you see the change in temperature. Okay, so the change in temperature here is around 7.7. okay, and here is just 2.3, and then from here is 5.5. Okay, so can we get a proportion here? Okay, so when the energy is increased by 1500, the temperature increased by 7.7. When it's 500, which should be 1/3 of the previous increase in energy. Okay, the temperature rise is only 2.3. It's 2.3 around 1/3 of 7.7. You can use your calculator to check. Okay, so 1/3 of 7.7 is actually around 2.5, so it's really close. Okay, and how about when it's 1000, when the energy increased by 1000, so temperature increased by 5.5. So it's a bit more than double of 2.3, but the energy is double. Okay, so roughly you can see that possibly we can claim that not only one is increasing, the other is increasing, but also the increment themselves are actually in a direct proportion. So that will be a much stronger proposition, right? Okay, so in this case, for these 2 marks, at least we should have 2 points to write. Okay, so let's have go. Okay, first we can say that the more heat is added, okay, the greater rise, okay, so that's a general statement, and then you can go into more detail. You can say, okay, in fact, okay, the heat added is directly proportional to the increase in temperature of the unknown substance. Okay, alright, so that will give you 2 marks. Alright, so if you only answer one very general trend, you only say that, oh, the more heat is added, the greater is the temperature, and then possibly you will only get 1 mark. Okay, because that's too general. But if you go into more detail, then you get the extra mark. Okay, so that's analyze evidence. Alright, okay, and remember, if you are going to identify relationship, you need to say, is one increasing, the other also increasing. In sometimes it might happen that one is increasing but the other is decreasing. Then you have to identify that. Alright, okay, and let's go to the last one. It will be the most interesting one. Okay. Okay, so the last one is to predict the initial temperature of the substance in the calorimeter before any heat has been added by using the 1000 and 6000 J data. Okay, so show your working. Okay, so here first of all you see it's about interpret evidence, and that's 2 mark. Okay, so remember, the interpret evidence will be the most difficult question in the data test. Okay, and the correlative word here is predict. Okay, so predict normally means that something not shown in the graph, so that's why you need to interpret. Okay, right, so something not shown in the table or not available in the graph or in the data, then you have to find out by some kind of interpretation. Alright, okay, and actually the question asks you to use, okay, you have to use the 1000 joule and 6000 joule data. So how can we use that? Alright. Right, so let's see. When it's 1000, the average temperature is 30.0. When 6000, the temperature is 54.5.2. Okay, but how could we use this data to find the temperature of the substance before any heat add? Okay, so what does it mean? Okay, let me give you some idea. Okay, let me copy this table. Alright, and let's remove the table here for a better understanding. Okay, so now you see the table start from what? Start from when 1000 joule has been added to the substance. But how about when there's no energy added to the substance? What's the temperature? So you need to imagine that if I move the table a little bit down, okay, and you need to imagine if that's 0 right here, that means no energy input. So what's the temperature here? Okay, so is that quite interesting? How could we know that? Alright, okay, so here we might need to use a bit of imagination. Okay, or you have to assume something so that you can do it. Okay, let's say the heating process is a uniform one. That means the energy input is actually directly proportional to the temperature rise, right? So then we should know something like, okay, the energy input, so that means the Q will be directly proportional to the change in temperature. Okay, right, so that makes sense. Why? Because we know we have a formula like this. Okay, so if there's no change in mass and the heat capacity, that means Q will be directly proportional to the change in temperature, right? So what does it mean when Q is directly to the change in temperature? That means Q divided by T should be a constant. Okay, right, so let's see how could we use this assumption. Okay, so we need to use the data from 6000 and from 1000 and 6000. So let's say from 1000 6000, how many heats has been given? So it should be 6000 take away 1000. So what's the change in temperature during that period of heating up? Okay, so during that time, you see the temperature changes from 30 degree to 55.2 degree. Okay, so delta T will be this one. Alright, so that's one part of that heat supply divided by change in temperature. Alright, but we could also use the other part, like how about from 0 to 1000? When you consider from 0 to 1000, okay, it should be 1000 minus 0 divided by what? Divided by 30. Okay, minus the temperature here. So this temperature we don't know, so let's say this temperature is T. Okay, minus T. Okay, so basically you are going to solve this equation, okay, to get you to find the T. Okay, let's do it. Okay, so that's 5000. Okay, so that would be 25.2. That would be 1000. 30 minus T. Okay, so I need to solve it, of course, and before solve it, let's simplify this a little bit. It's 1 and 5, isn't it? Okay, then we know that for two fractions equal each other, we can always use cross multiplication. you multiply that 5 into the equation. Okay, and of course, and then you will subtract this one to this side. Okay, sorry, I'm running out of the space. Okay, let's use calculator to find it. Okay, so okay, so T would be okay, so you will see that should be 24.96 from your calculator, right? But remember, we need 2 decimal places right here. Okay, alright, so that would be the 2 decimal place. Okay, so that would be our final answer. So our final answer would be 24.96. Okay, does it make any sense? Okay, so if we put temperature at 24.96 right here, so let's see, when there's no energy input, so that means the original temperature should be around 25 degrees. After 1000, increase 5 degrees becomes 30. That seems quite right, because whenever you add 1000, it seems the temperature change would be around 5 degrees, just like that happens from 3000 to 4000, and you see the temperature changes from 40 to 45.5. So actual data make perfect sense. So we know that's what we're getting correct. Alright, so this is my demonstration of the data test for you guys. Okay, good luck for your data test. Thank you.